Welcome to Python Basics with EJD. In this video, we'll be looking at the Python requests library for interacting with web APIs. Disclaimer, I've never used requests before, but I mean, since I'm talking about Python essentials, Python basics, so at this point, I've been talking about Python packages, right? So I'm introducing you to these different packages. The ones I'm very sure about are the ones for scientific computing like SciPy, NumPy, SymPy. Then of course I use pandas and all that. So, but when it comes to Python requests, I've never used it. So what I'm going to be doing, I may not actually even run any codes, but I'll just show you how the codes look like. For those that work with it. So, or if you ever have to work with APIs like that and you want to use Python. So this is just me introducing it to you, not because I've used it before, but I mean, I can show you how it will look like, at least so you can take it up from there. So Python request library for interacting with web APIs. The request library in Python is a simple yet powerful HTTP client that makes it easy to interact with web application programming interfaces, that's APIs. So, I mean, the whole idea of API is that you can connect two devices together and collect data from them or so, or make them change data between themselves or things like that. So, application programming interfaces. So, the request library does that it abstracts away low-level networking details and allows developers to send, get, and post requests, manage headers, query parameters, cookies, and sessions with minimal code. It supports authentication methods like basic AUTH, basic auth, if you like, and bearer tokens, handles JSON and XML responses seamlessly, and provides tools for file uploads or downloads, retries, and timeouts to ensure robust communication. So the idea of API is that you have devices communicating with themselves. So it is widely used for consuming REST APIs such as GitHub or OpenWeather. Request is the go-to library for Python developers who need to integrate external services or exchange data with web applications, right? So if you are designing an application that requires getting some external information, then of course you need to use web APIs. And of course, to do that in Python, you need the requests library. So first of all, the setup and the first look. So to set up, so like I said, I'm not going to be running any codes there because I'm actually not, I don't know I've not used request before, but I can show you how it will look like if you need to use it. So the installation, of course, as usual, you need to do pip install requests, right? And then, once, of course, I can show you how to install for sure. So just pip install request. I've installed it before, so it's just going to say requirements satisfied. But if you are doing it for the first time, it might take a bit of time. And once that it is installed, then you can go ahead and import requests, and then you have so since it's about APIs now, so if you have some websites you need to reach out to get some information, so you need to put that URL right here, and then talk about the timeouts, then the R status code, and blah blah blah. So this is how this whole thing looks like. So don't forget to always set a timeout in seconds. So this timeout now. So without it, a hung server can block your program indefinitely. So if you want since you are making things interact, right? If you don't give a limit to it, you can have your server hanging because it's what you are running is endless, right? So part of the things we have in request is get. So get is very important here. So maybe like you're getting information from another device. So you have the get requests. So you can query parameters, right? So you have params queue, Python request page, one per page, and blah blah blah. Okay, let me even run this for the fun of it. I'll just keep running. Most of it is going to give error, right? Okay, this is even fine. So, but most of it is going to give error. So, but if you really have all that is required, you won't get any error messages. So here now we are querying parameters, so it sends us a link. So if I click on this now, so because it's in blue, it takes us to a like kind of JSON environment. Then we have custom headers. So I run this. Okay, I mean that works. And then we go to downloading files or streaming. That's under the get request now. So I run this, maybe it's going to give error or something. Oh, it seems it works. So we have get. Now we talk about post request now. So you can get request. You can also post request. Since devices are interchanging information, or maybe they are sending one device is sending information to the other. All right. So you can post request. So you can have an encoded form like data, username is Alice, password is secret, then R is request.post, then you have the whatever link you're working on, like that. Then data is data and timeout is 10. So you run this again, and that works. Then you can have the JSON payload. So you say payload name is widget, price is 9.99, R is request.post, and blah blah like that. JSON is payload, timeout 10. And then you have this. Okay, then you can also have file upload, which can be multi-part of form data. So with open report.pdf, RB is as F and blah, blah. So if I run this now, maybe an error, yeah, we get an error message because it says there's nothing called report.pdf. So if I had a report.pdf, then maybe that we can have access to that. So don't forget, I'm just showing you how it might work if you have to work with the requests library in Python. Okay, so here we talk about authentication. So you have the basic authentication, or basic auth for short. So from request.auth import HTTP basic auth. So it means HTTP basic auth is actually some kind of function or module inside of the request.auth. So you now have our request, blah blah blah, and you have this Alice secret. So that works good. They have the bearer stroke API token. So most modern APIs use a static token or OAuth2 access token as a bearer. So your token is your token header, your authorization, bearer token, and blah blah. So you run this. Of course, there's an error because we don't have all that is required. But then I'm just showing you what to expect. So OAuth2, which is high level. So OAuth2 flows. You have auth code, client credentials, device code, typically yield an access token you then pass as bearer. Then token exchange itself is often handled by an auth library, e.g. request dash OAuth live or done manually against the provider's token. And then you can have this after you obtain access token via this, you can have the headers and the request. Of course, that's an error as expected. Then you have sessions now. So you can go for sessions, which is for connection reuse, default headers and cookies. So you have session keeps TCP connections, open faster, persist cookies, and all this. So you also have this. So maybe this is going to return KV. Yeah, this works. Then for robustness, like timeouts, errors, retries, and backup. So for timeouts, first of all, you have the connect timeouts to establish connection. And then you have read timeout, which is time waiting for first byte of response, right? So, this is all information being transferred between devices, all right? So we get like 200 responses from that, Then for error handling now, you have, oh yeah, I think we've seen something like error handling from I think it's Python control flow where we talk about error handling. So when something goes wrong, so when you see all this HTTP error 503, 404, and all this, then you can have retries with backoff. All of this, the backoff thing is part of the robustness thing we were talking about initially. So retries with backoff. So you run that. Of course, maybe we are most likely going to get an error since we don't really have all the facility for requests per se. So it's taking some time. And then we have the possible errors, 429, 500, 502, 503, 504. Okay, and then we have there are too many 503 error responses, of course, for obvious reasons, because I'm actually not implementing anything actually. I'm just showing that how these things work. So handling JSON and XML responses. For JSON, you have something like this. You have this whole kind of coding if you're working with JSON. So for the tips, you validate structure. So use .get with defaults and consider pydantic stroke data classes for typed models if responses are complex. For XML, many APIs still return XML. So you use the standard library on LXML, which with this kind of coding right here, it's for XML. So that one brings it some slide title, wake up to wonder widgets, slide title overview, item Y, EM wonder widgets, item none, item who, EM buys, and all of these things. Then we have pagination patterns. So you have page and limit parameters like that. So, if you run this, you have page one, cause error for obvious reasons. Then you have the link headers, GitHub style. So if you want link headers, you can actually have them, import RE and all these stories. So if you run this now, you get this going. So, of course, it's taking so much time. Let's see what it brings. Okay, of course, obviously an error as expected. So rate limiting and polite usage. So you need to check headers, e.g., H rate limit remaining, retry after, Honor 429, too many requests with backup, use caching when possible, like e-tag if non-match, avoid excessive concurrency, keep sessions and retries reasonable. Then for 40 proxies, SSL and redirects, we have all this. You have proxies, SSL verification, only disabled for control scenarios, redirects defaults, blah blah. You have all of that, you know. Then yeah, so then we have testing and mocking. So you can use HTTPS, httpbin.org to simulate common scenarios. So for unit tests, you prefer mocking like responses library or request mock to avoid real network calls. Then we have consuming real REST APIs. That's one of the things request does. So it can consume real REST APIs. So you have the GitHub REST API for public endpoints and no authorization. So the goal is to get top Python repos matching a query and print name to stars or so. So with this now, so if you run this, yeah, we get something like this. PSF request 53,241, young pin, cutoff free VIP 34970, Wispin, and so on. We have marking and retail and all of these things. Then you have the with token, which talks about higher rate limits now. So if you run this, you get of course, an error. So 401 client error. So pagination with link header is shown in 7.2. GitHub also returns H rate limits, headers, check, and backup as needed. Then you have the OpenWeather API, which requires API key. So the goal here is to fetch current weather for a city and pass JSON safely, right? So if you're getting weather for a city like that, so from OpenWeather API, so it's possible if we work with that weather data. So of course, we have a 401 client error again. So this, I think, of course, for obvious reasons, we expected that. So for the notes now, prefer units is metric or imperial. All right. Um, so I think the whole pound feet and meter kg kind of paradigms, right? So for forecast, you can use forecast or one calling point, handle lists of time slots, consider rate limits. Now putting it all together, you can have a reusable API client skeleton. This is how it looks like if you need to put the whole thing together like that. So from data classes, import data class, from typing import any, from then import request adapters. I mean, from request adapters, you import HTTP adapter, from URL lead3.ut retry, import retry, then data class. You have all of these things, and then you can just run that. Of course, we might, oh, seems to work. That's fine. And then some common pitfalls and best practices. First of all, no timeout. So that's risk of having for hanging forever. So if you don't have a timeout, like we've said initially, that timeout is like 10 seconds or something. So you have to always set it. If you don't, you risk there's a risk of hanging your device forever because it's more like when you are running a numerical analysis thing and it's running forever because it's not converging or because you did not set a limit for it to stop. Then that's endless infinite loop. So retry unsafe operations. So be careful retrying post, put, patch, and delete. Ensure idempotence or server-side deduplication. Then unbounded pagination loops always include a termination condition. Very important. Blindly trusting JSON shape. Use .get with default or schema validation. Leaking secret. Don't log full headers. Use environment variables or a secret manager. Ignoring rate limits like read headers back off from 429 by 5xx, then over specific user agent, set a descriptive one. Some APIs require it. So some quick reference and cheat sheets for the request library for working with web APIs, right? So you have request.get, so you need a URL, a website link that is, then you need the parameter, the headers, and the timeout. Very important timeout to avoid hanging. Then you have request.post, you need a URL, you need the data, you need the JSON, the files, and the timeout. Then for request.session, so that's for connection, reuse, default headers, and authorization and cookies. Response.json, response.text, response.content, that's another thing you need. Response.raise for status, for FX, 4xx, and 5xx. Then retries, you retry plus HTTP adapter plus session mount, pagination via page/limit or link header, authorization HTTP basic auth, bearer tokens in authorization header. Then for file download, you have stream equals true plus item count and xml.e3 elementary element tree, then dot from string. That's talking about the rest, and then you have the response content. So, I mean, this is just me introducing you to the whole idea of the Python request library, which is particularly useful for interacting with web APIs, where APIs are application programming interfaces, which is talking about exchange of information between devices. So with this, I come to the end of this video. Let me know whatever, how helpful this is for you. And if there's something you'd like me to try out, feel free. If you have subscribed already, thank you so much. But if you have not, of course, you're missing a lot already. So go ahead and subscribe and hit the notification bell so you can always get alerted each time a new video is released. After that, you can take it a step higher by clicking on join to become a member of my channel. That gives you some special privileges for sure. Part of the special privileges might be having some videos exclusively for you, or even at the highest level, we can have one-on-one interactions for sure. So ultimately, don't forget to comment, like, share, so that more people can have access to the great content I have going on here. So like, come your way again, keep doing Python right. Bye.